plenty of room to take notes still, don't you? Alright, so I'm going to teach you the skill that we're going to need for day 6, and you will have that under your belt for Monday. We probably won't do a lot with it yet, but at least you'll have it. Alright, are we on?
Yeah.
Okay. Ready to go. The next part, that's it for conditional probability. We just fly through this stuff, don't we? I'm going to toss a coin twice, and I'm going to teach you how to find probabilities with a simple case on a tree diagram. I love these things. Alright, tree diagram, because I don't have to think. They just do the work for me. So I'll teach you with an easy one, and then I'll give you a different one, and see if you can do the same thing in a more complex setting. So I'm going to have a coin toss. So you have to indicate to the reader what you're doing, what the event is. So what are the possible solutions? Well, it could have been a head, and it could have been a tail. So that's your first couple branches. Now let's go down the head branch, and what are the possibilities for the second toss? Also head, tail.
Oh boy.
And what's the possibilities of, if your first toss was a tail, the second could be heads or tails. Do you see the first toss are lined up here, and here's the second toss. So these are all the possibilities right in front of you. A tree diagram is not finished until you put in the probabilities. So what's the probability on the first toss of tossing a head? All right, we know we've said this 1,000 million times, so that's 1/2. And after that, on the second toss, if your first toss was a head, what's the probability your next toss will be a head? They don't affect one another, so it's 1/2. So all of these are 1/2s. So now we can easily visualize what is the probability of tossing a head and then a head. The way you do that with a tree diagram is you go down the branches that you've described in the problem. So I'm going to go head and head, and you take the numbers that you put on the branches and you multiply them. Does that make sense to you? You probably would have come out with it without a tree diagram, just because you know if you flip a coin 2 times, you could either get head, 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 tail, tail, head, or tail, tail. So this is one of the 4 possibilities. But it gets more complex when you look at other problems. So in fact, what's the probability of any of these? Okay, what's the probability of tails, head? What's the probability of tails, tails? What's the probability of heads, tails?
1 in 4.
Yeah, they all came out the same. Like I said, I would train you. I could train you on an easier one, and then we'll flip to a more complex one. Not very complex, but more. Alright, the one we're going to train on is the same one with handedness. So we're going to do the same thing for handedness. A tree diagram for handedness. So you still have that information in front of you? Alright. So I'm picking a person at random, so I have to tell you what I'm doing. Random student selection. So, the way we're looking at this, we're taking 2 students. Random selection of 2 students. And we're going to look at their handedness. That's all we're looking at, their handedness. I never heard that word, handedness. That view of that word. All right, so let's do student number 1, and that student could be, say, left-handed, and student number 2, this is still student number 1, the choices. For the first one, he could be right-handed. All right, so let's go ahead and do the tree, and we'll come back and put in the probabilities. So this is your first selection. You see they're on top of one another. So now we go to our second student. And that student could be left-handed, so this is number 2, or it could be right-handed, student number 2. And then the other one's left and right. So it looks something like the coin toss in that here's the possibilities. We could get 2 lefties, a left and a right and a left, or 2 rights. So it looks very similar, but the probabilities are way different. So we have the chart to look at to figure out what they are. So can you help me? There's 1, 2, 3, 4, 5, 6 probabilities to come up with. So looking at the number on our chart, what's the probability randomly selecting one student and they're left-handed? Can you grab that from the chart, MK?
So that's 4 and
Yeah, let me get my little chart back up real quick. 3, 18, 1, 6, female, male, 4, 24, 21, 7, and 28. All right, so her job is first selection, what's the probability of being left-handed? And she grabbed this number over this number, 4 out of 28. I know that's 1/7, but I'm going to keep it simple and leave the denominator in so you can see where the numbers came from the chart. All right, what is the probability of it being right-handed, MK?
right-handed, 24 and 20.
I'm sorry.
24 out of 20.
All right, so you went over here, grabbed this number, 24 out of 18. 18 out of 24. No, 24 out of 28. Sorry, I knew there was an 8 in there. All right, now this is where it gets a little tricky. We've already selected student number 1, and he's left-handed, so he's no longer in the mix. So when we go to pick the second student, Brian, can you muscle through that with your brain? Since we've already picked one lefty, they're not in the mix anymore, so you can't use this number.
Yeah.
So and you can't use this number.
Mm-hmm.
So what number will you use?
It'll be like, what, 3 out of 27?
He got it! Ding, 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 good. All right, it's Friday and you look tired, but you got it, Brian. All
I'm a bit
right,
tired,
okay, well, you got it. So. All right, you can see how these probabilities aren't as straightforward as the tails and the heads, and we'll finish it, but you can see the gist of where it's going. All right, MD, hope that your time away from us was worth it. All right, we'll see you on Monday. Bye.
Bye, Em.
And